Hi everyone, welcome back. We just now have been talk about how to sketch the graph, how we determine the graph. You don't have to remember what is the vertices or anything, as long as you know how to determine from the Cartesian equation. We also talk about the parametric equation here. Okay, so this is the parametric equation. I am going to copy the first part of the parametric equation here. Alright, in order to talk about something that is deeper where it called as the equation of the chord. So let's say I am here to sketch the graph of the parabola. Okay, so this parabola here, let me do adjustment. Okay, maybe I'm not going to sketch because this is x squared, right? So I have to change this. Let me adjust. Okay, adjust. Okay, should be something like that. All right, and then we have a parabola that pass through the center. The vertices is the center. Okay, it's a bit ugly. Let me sketch it nicely. Pass through the center, and this is the parabola graph. So let's say this is a y-axis, let's say this is the x-axis, then any point on the graph, on the curve of parabola, name it as P and Q. Let's say the focus is somewhere here. This is the S. So the P equation will be 2AP AP squared. So this is how you apply the parametric equation. If you put a P here, then the T will change to P. If you put a Q there in the curve, then it will be 2AQ AQ squared. Alright, so now let's say I want you to form a chord equation. So a chord equation is from P to Q. I want to form this equation. First of all, I have to find the gradient of PQ. Alright, to find the gradient of PQ, of course, is y2 minus y1. AQ squared minus AP squared equal to 2AQ minus 2AP. So in this case, you can actually factorize out the A. Okay, this is the A, not 9. So Q squared minus P squared, and always factorize out the 2A on the bottom. So you get Q minus P. And the A you can cut away. Q minus P on the top, Q plus P on the top. You factorize this, and you should be getting 2 over Q minus P, 2 times Q over minus P. Then final answer is not here, you just cut away so that you get your gradient of PQ as Q plus P over 2. And to form the equation, I need to use y minus y1. For example, I use AP squared this time here, equal to your gradient Q plus P over 2 times x minus 2AP. Alright, the whole equation I times 2y minus 2AP squared equal to Q plus P x minus 2AP, and in this case, I expand the equation. So I should get Qx minus 2APQ plus the Px minus the 2AP squared. So in this case, I try to see anything that I can cut, I cut away. Alright, so in this case, let me analyze the equation here. As I can see, this is minus 2AP, I can cut away. So then I will left with 2y equal to Q and plus P. So it will be Q plus P with x. Okay, these two I factorize, minus 2APQ. And y at the end will be Q plus P over 2 x minus APQ. So meaning to say, in this case, this is the equation of the chord. Then let me ask you, what would happen if the chord now, I want to find the equation of tangent. Let's say this is the tangent line. Okay, this is the tangent line at point P. Touch the curve at only one point, which is here. Okay, touch the point only here. don't think about this, because maybe my curve is not so nice, so it might be a bit how should I say, a bit not so good to have an imagination. But just remember, P is the tangent. So now I am trying to find this tangent equation. To find tangent equation is actually very easy. Alright, so like what I say, this is the equation of x and y. In order to find gradient of the tangent, equation of tangent, you always find dy dx. And in this case, to find dy dx, you need some skill from the differentiation. So as I know, x equal to 2at and y equal to at squared. From here, if I dx dt, I should get 2a, and from here, if I dy dt, I should get 2at. So in order to get dy dx, I need to open up as chain rule and times it on with dt dt here. dy dt gave you 2at from up here, and dt dx is actually 1 over 2a, where you are cut away the 2a and you are left with t. Meaning to say, the gradient of tangent is defined as t. So meaning to say, if I put the point P here, okay, the gradient of the tangent this line, this equation, will give you gradient of P. Okay, alright, because of this proof here. So in order to find equation of tangent, y minus the P, which is AP squared, equal to the gradient P x minus 2AP. So this is the equation. Then AP squared equal to PX minus 2AP squared. So in this case, you can see that there is a trend here. Okay, this trend, I'm going to bring the minus AP squared to that side, become plus AP squared. So I will just left with 1 negative AP squared. Meaning to say, the y-intercept here will be your negative AP squared because of this here. And this shall be your equation of tangent to the line, to the point of P. However, we can actually deduce the equation of tangent from the equation of chord. So what happened? Let me bring all this to the second slide. Okay, copy. So in this case, like what I say, equation of chord can be determined as equation of tangent. So why? This is because when I have a chord like this, can you see? The chord can be moved. Oops. The chord can be moved closer and closer and closer and closer, and at the end, it moves until a tangent of the P. No more Q. Meaning to say, the Q will go closer, go closer, go closer, and same point as the P. So in this case, if I put limit the Q, because the Q goes closer to the P, Q to the P of the equation Q plus P over 2x minus APQ. At the end, my Q is equal to P, so P plus P over 2x minus A times P. So at the end, you should be getting 2P over 2x minus AP squared. At the end, it will be Px minus AP squared, where this is your equation of the tangent. You prove that these two are the same. So that's how the equation of tangent comes. Alright? Without further ado, I am going to talk about one more thing that would be in your exam also, the focal length. So, the focal chord. Alright, so let me use another example. This is the graph here. A focal chord says that the chord will go through the S point, the focus. So meaning to say, this is the graph, okay, and this is the focus, the S, the A0. So meaning to say, if there is a focal chord, the chord will go through the focal and form like this. Alright, this is called as the focal chord. So how do we determine the focal chord? Is by applying the chord equation, y equal to p plus q over 2x minus apq, just now what we defined, and we are putting in the s coordinate a0 into the equation. So in this case, if I put in a, because this is 0, minus apq, x equal to 0, sorry, x equal to a. Did I just write wrong something? Yes, my s is not a0, I used wrong coordinate. My s should be the 0a instead of a0. Okay, the reason is because my s is on the y-axis. Okay, so 0a, I substitute in so that my my y is a and my x is 0 because times 0 minus apq. Alright, in this case, I can see that a is equal to minus apq. I bring my minus a to that side so that pq will become a divided negative a, where pq is equal to negative 1. So what does this mean? This means that when you have a focal chord, this is one of the properties. P times q will be negative 1. Okay, so meaning to say p and q here, the gradient, if you times together, it should be negative 1 because the p gradient and the q gradient. So for example, let's say I have the p gradient here and the q gradient here. When they times together, it forms a perpendicular line. So meaning to say p is your m1 times m2 will equal to negative 1. Okay, and in this case, when we try to prove something like this, this says that at one point the p and q will meet at the r point. So this r point, you have to prove it out and shows that what is this point r, and this point r is always will be lies on your directrix. Okay, so this directrix is y equal to negative a. It will always lies on the directrix. Alright, so always remember that the properties of pq minus 1 is because you pass through the focal chord and it formed by substituting into the equation of chord, and that's why you get pq equal to negative 1. These two tangent line, because p is the tangent of the point p, and q is the tangent of point q, these two gradient will intersect at r, and this r will be at the directrix, and they form a 90 degree. Alright, so that's what you need to know in parabola, and thank you so much for listening. I will see you in the ellipse chapter.